Now we will continue with the problems about photoelectric effect. Question number 1, photoelectric effect equation. Light of energy 4.14 electron volt shines on lithium, which has a work function 2.3 electron volt. What is the maximum kinetic energy of photoelectrons? Einstein's photoelectric equation says that energy of the photon is equal to work function H times FO plus maximum kinetic energy of a photoelectron. So if I want to calculate maximum kinetic energy, I have to subtract from energy of the photon how much energy is used as a work function. So the difference is going to be given to the electron as kinetic energy. Energy of the photon 4.14, work function 2.3. So then when we subtract them, we are going to get the answer as 4.14 minus 2.3. Answer is 1.84. So 1.84 electron volt kinetic energy will be given to photoelectrons. Question number 2. At the photoelectric effect, it is found that when the photon of energy 8 times 10 to the power of 19 joule, so this is energy of the photon, incident on a metal of surface. Electrons ejected with the maximum kinetic energy. This is maximum kinetic energy maximum. Find the work function. What is HFO? HFO, but we will find it in electron volt. So we know E is equal to HFO, which is work function, plus maximum kinetic energy of the photoelectron. So because I will calculate HFO is going to be E minus maximum kinetic energy of the photoelectrons. Energy of the photon is given as 8 times 10 to the power of negative 19 minus maximum kinetic energy 4.8 times 10 to the power of negative 19. If we do this operation, we will get result as joule, but choices are given electron volt. But if I divide this by 1.6 times 10 to the power negative 19, I will calculate result as an electron volt. So 8 times 10 to the power of negative 19 minus 4.8 times 10 to the power of negative 19 divided by bracket 1.6 times 10 to the power of negative 19, close the bracket. Answer is 2. So 2 electron volt is the answer. The graph shows a linear relationship between the maximum kinetic energy of the emitted electrons and the frequency of the incoming light. So relation is linear. The graph is given. So what is straight line slope representing? Remember, it was Planck constant. Planck constant is kinetic energy maximum divided by frequency, delta F it was. So that's why this slope is Planck's constant. And question number 4. For light, each has 1 joule of energy. Total energy of the light is intensity. This is in fact intensity. And their wavelengths are 650, 600, 400, 500, 450. The number of photons of which light is smallest. Remember, there was a question similar to this one in the previous title. Intensity determined by number of photons. And each photon has energy H times F for any light. If you multiply by the number of photons, we will calculate intensity and total energy. If I want to find, and I have to, then how many photons included, I have divided total energy by energy of a single photon. But this is written in terms of frequency, but given values are in terms of wavelength. So I'm going to write energy of, but in terms of wavelength, C instead of F, I will write C divided by lambda. Lambda, it goes up numerator, E times lambda divided by HC. HC is a constant number because Planck constant speed of light doesn't change. E is given 1 joule. So number of photons and wavelengths are directly proportional, as you see. And which light has greater number of greater wavelength, longer wavelength, it will have greater number of photons, of course, 650 650 as the longest wavelength. 650 will have the greatest number, pardon, as smallest number, opposite. So smallest wavelength, smaller number of photons. Smallest wavelength is 450. So 450 nanometer will have smallest number of photons. Question number 5, a light source of wavelength lambda illuminates a metal and ejects photoelectrons with a maximum kinetic energy 1 electron volt. A second light source, wavelength is lambda volt, ejects photoelectron with a maximum energy of photoelectron. What is work function? So the same metal, I'm going to write Einstein's photoelectric equation, which is equal to E is equal to work function plus maximum kinetic energy for both metals. Let's write for the first metal. It say that wavelength, this lambda wavelength has an energy E. A second light has wavelength lambda which as wavelength halved, energy doubled, so it becomes twice. Yeah, and second light has twice the energy of the photon of the first one. So I will write for the first one, if I say energy is E, because metal is the same metal, I will say HFO, but maximum kinetic energy 1 electron volt. For second metal, because wavelength is halved, energy of the photon is doubled, yani 2.2e, and HFO is the same metal, but this time kinetic energy becomes 4 electron volts. I will calculate HFO, so which means instead of E in here, there are several ways for doing such problems, but I'm going to do one of them. Generally, student can understand better. Instead of E in here, I'm going to write HFO plus 1. Yeah, and 2 times of, instead of I write HFO plus 1 electron volt is equal to HFO plus 4 electron volts. Then distribute this over 2HFO plus 2 times 1, 2 electron volt is equal to HFO plus 4 electron volt. Transfer HFO to the left side, 2 electron volt to the right side. 2HFO minus HFO is equal to 4 minus 2. So HFO is equal to 2 electron volt is the answer. Question number 6, this figure represents is about Compton effect, Compton shift. When a stationary electron is hit by a X-ray photon, so it scatters. This is known as Compton shift. Which of these phenomena provides support for Einstein's photon theory of the light? Compton shift. Compton shift is the answer. Which of the following shows that photons have linear momentum? Again, Compton shift. So these are the all about 2 more questions. Question number 9. To measure the Compton shift, which of the following waves are simply used? X-rays, because they should have very high frequency, very short wavelength. So X-rays are used. Yeah, and Compton effect, Compton shift is noticeable at very high frequency, shorter wavelength waves, not visible, not infrared, not microwaves. Question number 10, in an X-ray photon is scattered by a stationary electron, how does the frequency of this scattered photon change? Of course, energy is shared. Incident photons energy is shared by the energy of electron and scattered photon. That's why if energy decreases for the photon, so its frequency must decrease as well. So scattered photon has no frequency, scattered photon new frequency is going to be lower, yeah, and lower frequency, but longer wavelength, yeah, and scattered photon, remember. So when there's an incident electron, the resting electron, if a photon incident is incident photon, and after that, electron recoils, photon, and then scattered photon, because energy is shared. So energy of the scattered photon must be less energy with small frequency, longer wavelength. So D is correct answer for this question.